All right, here is a review video for our conics test. So first one, draw the circle with the following equation, identify the center and the radius. So what to remember here, x minus h squared plus y minus k squared is equal to r squared. Okay, hk being our center, so in this case, 3, -1. Again, it's x minus h, y minus k, so think opposite of what you're actually seeing in the equation. Okay, then we got an r squared value of 16. So to figure out the actual radius, square rooting both sides will get us a radius of 4. So when graphing then, go to your center, 3, -1, up, down, left, and right, 4. And then drawing your circle. Okay, that's what it comes down to when graphing a circle. Okay, writing the equation of a circle now. Our goal is just to write the equation. Coordinate plane there is just to help us get a visual. So we got a center at 1, 1 and a point of 5, 9. Okay, so remember, we can create a right triangle and we need to figure out that r. Okay, so you can use the Pythagorean theorem. You got a distance of 4 there and distance of 8 there. Now, if you just use the standard form of a circle, it will end up being exactly the same thing as using the Pythagorean theorem. Okay, so plugging in our center, and again, hk. So in this case, we got x minus 1 squared plus y minus 1 squared is equal to that r squared. Then using that other point as xy, plugging that in. So we got 5 minus 1 squared plus that 9 minus 1 squared to give us r squared. So 4 squared plus 8 squared to give us r squared, or 16 plus 64 equals that r squared, which adds up to be 80. And again, when we're writing the equation of a circle, we want r squared in our equation, so we can stop there, and we'll end up with x minus 1 squared plus y minus 1 squared is equal to that 80. So there is writing the equations of a circle. Okay, so ellipse now. Okay, we find our center just like we did before. Got a center of 2, -3 here. 2, -3, plotting that. Okay, and again, to figure out vertices, co-vertices, vertices are going to be the points that are further away from center on an ellipse. Okay, so figuring out those points, under x we got 25. Okay, and again, we want to square root that value, so that's telling me left and right, 5 from center. Okay, under y is 16, square root that, up and down 4. Okay, and now we have our ellipse. Again, I like to label which points are further away. We went left and right further, so those are our vertices, while the up and down points are our co-vertices. Okay, so our vertices are -3, -3, and 7, -3, while our co-vertices are 2, 1, and 2, -7. Now, to figure out those foci, again, we're going to use c squared is equal to a squared minus the b squared. Remember, it's always going to be opposite of the standard form in that c squared equals a squared minus b squared. Okay, so again, now a squared and b squared, in the cases for an ellipse, a squared is always the larger one, so 25 minus 16. So keep in mind, you will always get a positive value for c squared in this case. So c squared is equal to 9, or c is equal to 3. Now, remember, that c value is the distance from the center to the foci. Okay, and it's always falling on that major axis, which is between the two vertices. Okay, so we're going to go left and right 3 from the center. And in those points, we got -1, -3, and 5, -3. So remember, if we go left and right, we're changing the x coordinate of the center. Okay, so that x coordinate, you're just adding and subtracting 3 to that 2. Okay, and the -3 will stay the same since we went left and right, then go up and down from the center. All right, so writing the equations then. Okay, so plot what we know. We got vertices at negative 8, 3. 2, 3. And then foci at negative 6, 3, 0, 3. So then from there, okay, again, label what we know. So those are our foci and our vertices. Okay, and from there we can figure out our center. Okay, I'm looking at those foci. We got a distance of 6, so half of that is 3, which puts us at negative 3, 3 for our center. Okay, so and again, when it comes down to writing the equations of these, it's figuring out the center and figuring out your a squared and b squared. Okay, to help us figure that out then, we got that distance between the center and foci, which is our c value, which is 3. And then we also have the distance from the center to our vertices, which will be a, which in this case is 5. So we got a, which is 5, meaning a squared will be 25. B, we do not know that, but we do have c, which is 3. So c squared is 9. From there, to figure out the b value, we're going to use our c squared is equal to a squared minus b squared. So in this case, 9 is equal to 25 minus b squared. So 16 is equal to negative b squared, negative 16, or b squared equals 16. Now keep in mind, we don't need to worry about b unless we are graphing. Okay, so since we are writing the equation, we do not have to worry about that. So x minus h, which will be x plus 3 squared over something. Sine for an ellipse is always plus. Y minus 3 squared over something is equal to 1. Okay, so what I always do, I don't even worry about a squared and b squared. I know I went left and right 5, so that 25 needs to go under x. Under y, okay, that's going to be the b squared value, so 16. All right, so graphing a hyperbola now. Okay, so we're going to figure out our center, which is negative 2, 4. Okay, so center of negative 2, 4. Okay, and we're going to use that same idea we used with ellipses. Under x is 64, so we're going to go left and right 8. Okay, up and down 4. Now, with the hyperbola, this is where we create a box. Okay, and then from that box, we're going to draw our asymptotes by drawing the diagonals, so center to each of the corners. Then from there, we got to determine which way this hyperbola is going to open. Okay, so since x is the first term, that means we're going to open up left and right. So our two branches will go left and right. And again, the further we go along an asymptote, the closer and closer it should get. Okay, make sure you do not cross over those asymptotes. Now, when it comes to the vertices of a hyperbola, those are the points that the two branches actually go through. So in this case, we got negative 10, 4 and 6, 4. Okay. Foci, we're going to have to figure those out. So c squared is equal to a squared plus b squared in this case. Again, opposite of the standard form. So c squared is equal to 64 plus 16, which will get us a c squared value of 80. Okay. Now, to actually plot those, we're going to need just c, which is going to be the square root of 80. And if we break that down, 8 times 10, 2 times 4, 2 times 2, 2 times 5. We got two groups of 2's. So 2 times 2, which will be 4. And then we got that 5 left inside there. So 4 root 5. Okay. Now, square root 80, that's going to be about 8 point something, because I know square root of 81 is 9. So we're going to go 8 and a little bit further. There's my foci there, foci there. Now, when to actually to figure out the actual points of those foci, again, we went left and right. So we're going to change, or we're going to add and subtract to that x coordinate of the center. Okay, so we went negative 2 and we added that 4 root 5, and the y coordinate did not change. We went from -2 and we subtracted that 4 out 5, and the y coordinate did not change. Okay, so there's our points to our foci. For the asymptotes again, remember y minus y1 is equal to plus or minus. Okay, we got to represent both asymptotes. The slope times x minus x1. Okay, and our slope, or our x1 and y1 are just going to be our center. So y minus 4 is equal to plus or minus the slope, which when we figure out our slope, we're just going to go to our box and go. I always go from the center to the top right. So we went up 4, right 8. Rise over run is 4 over 8, which I need to write as 1/2 to simplify. So plus or minus 1/2 times that x plus 2. What you're going to notice is those will end up being the same as what you see in the standard form as well. Okay, really it's just a matter of figuring out that slope. Okay, write an equation of a hyperbola with the given characteristics then. Again, plotting what we know. Okay, so I'm going to go to my vertices 2, 3, 2, -3. Okay, from there I can figure out my center, which will put us at 2, 0. Okay, so actually from there I can determine which way it opens. Okay, this one should go up and down, meaning y will go first in our equation, because again, on a hyperbola, what variable comes first determines which way it opens. So in this case, y should come first. So I can write half of my equation, y minus 0, which would be just y squared over something. And the sign on a hyperbola is minus, times that x minus 2 squared over something, and it should be set equal to 1. Okay, now, from what I got, okay, 2 and 2 root 3, 2 root 3 is going to be about 3.4, 3.5. Okay, so we're going to go up and down from that center, about 3.5. Now, that's just to help us plot those. What we need to remember is we need to use that 2 root 3. Okay, so from center to vertices, that's going to be our a value, which was 3. Our center to our foci then, which is c, is going to be that 2 root 3. So a is equal to 3, meaning a squared is 9. B, which we don't know yet, so meaning we don't know b squared. We do know c is that 2 root 3. So c squared is that 2 root 3 times 2 root 3 over 4 times 3, because root 3 times root 3 is 3. So we get c squared as 12. So c squared is equal to a squared plus b squared then. We got 12 is equal to 9 plus b squared. Subtracting that 9 over, we get 3 is equal to b squared. Okay, so when writing your a squared and b squared in there, again, I just look at the actual graph. We went up and down 3, so that's going under a y, and we got to square that, so 9, and the opposite value that we had was 3, so 3 will go under x minus 2 squared. Okay, so parabolas then. So when we do parabolas, again, we find that center with x minus h, y minus k. In this case, it's just 0, 0. Then from there, we got to determine which way it's going to open. Okay, we got y equals, so it's going to go up and down. Okay, then from there, we're going to do our table. Since it's y equals, in our table, we're going to have y equals that a value of 1/4 x squared. Okay, and then figure out good values to plug in for x. Like 1 squared times 1/4, it's going to be 1/4. I don't want to use that, so I'm going to use 2. 2 squared is 4. Divided by 4, we're going to get 1. 4 would be another good value. 4 squared is 16. 16 divided by 4, we get 4. Okay, so then from there, that's saying right 2, because again, x is telling us left and right, y is telling us up and down. Right 2, up 1. Right 4, up 4. Okay, and then this is opening up since it's y equals, so we're going to reflect this way to get a parabola that opens up. Okay, so then again, we have the vertex of 0, 0. And to figure out that focus, again, we need a is equal to 1 over 4p. A value is 1/4, so 1/4 is equal to 1 over 4p. cross multiplying, we're going to end up getting 4 is equal to 4p. Dividing by that 4, we get a p-value of 1. P-value, again, is the distance from the vertex to the focus and the distance from the vertex to your directrix. So we got to go 1 away, which puts our focus at that 0, 1. And our directrix of a horizontal line, so y is equal to, and it goes through, -1. All right, so writing the equation of a parabola then, plotting what we know. So we got 5, 3. Got a directrix of x equals, so meaning a vertical line that goes through 3. And then from there, we can figure out our center, because the center will be right in the middle of the directrix and the focus, which puts us at 4, 3. So we got a vertex of 4, 3. And we can also determine which way it opens based off the focus, because again, the focus should end up inside the parabola. So that's where our parabola would go. Okay, so it's going right, meaning it's an x equals. So if you remember, x minus h is equal to 1 over 4p times y minus k squared. And you'll be given that in the test. Okay, you just need to be able to determine that that is that horizontal parabola. Then from there, because we have h and k, the only thing we're missing is that p-value. And the p-value, again, is the distance from the vertex to the focus, or you can do it to the directrix. In this case, it is 1. So when writing our equation, x minus h, so x minus 4 is equal to 1 over 4 times 1, which would be 4, times that y minus 3, and do not forget your square. Okay, if you forget the square, it is not a parabola anymore. It is a line at that point, so make sure to square one of the variables, and in this case, the y. All right, so classifying conics now in expanded form. So again, when classifying, you're looking at the squared terms. Okay, when looking at those, okay, they're both positive and they have the same exact coefficient. When that happens, that is a case of a circle. Okay, coefficients were the same, both were positive. Okay, on number 10 here, 5x squared, that is the only squared term. Okay, so in that case, when there's only one variable that's squared, that is a parabola. Okay, on number 11, we got 4x squared minus that 3y squared. Okay, so when both x and y are squared and one's positive, one's negative, that is a case of a hyperbola. And then finally on 12, 2x squared, 16y squared, both x and y are squared. They are different and positive. That is a case of an ellipse. Okay, so that's classifying. Okay, rewriting conics now. Okay, expanded to standard is a little bit harder. So what we need to do again to get from expanded to standard is we're going to complete the square with both x and y. So in order to do that, we're going to get our x squared, or x terms together. So we got 16x squared minus 32x. Put our y's together, plus 4y squared plus 64y, and then leaving that constant on the right side. And if that constant isn't on the right side, bring it over to the other side. So completing the square with those terms, completing the square with those terms. Okay, and again, when we complete the square, we need to make sure that that coefficient with the squared term is 1. Okay, so in that case, we're going to factor out a 16. It'll give me x squared minus 2x, and I'm going to leave a space for that term we're going to add. Got to factor out a 4 with the y, so we got y squared plus 16y. Oh. Plus some value is equal to that negative 208 plus something. Because again, if we're adding something here, we need to add it to the right side in order to stay balanced. Okay, the value that we add in each of those spaces, remember, half the b value squared. So half of 2 is 1. 1 squared is 1. Half of 16 is 8. 8 squared is 64. Now, the one thing you need to remember, though, is I am not truly adding 1 here. We got times 16, so I'm adding 16. Okay, on the other side, 64 times 4, we're going to get 256. Okay, then from there, now we have our perfect squares. So we got 16 times x minus 1 squared. So again, half of negative 2 is at negative 1. It's always going to be just x because we made that a value 1. So we have x minus 1 squared plus 4 times that y plus 4 squared. Oh, y plus 8, sorry. Is equal to, what do we got here? 64. Okay, and again, if you remember, 16x squared, 4y squared, this is an ellipse. For an ellipse, we need it to be set equal to 1, so we're going to divide by 64. Okay, so if you cannot see that those simplify, because again, in standard form, we need these to be 1. So these should simplify. And if you can't do that in your head, what you're going to do, 16 divided by 64, hit enter. You're going to do math, enter, enter. That'll change it to a fraction, which gets us to, 16, that's not right, 16 divided by 64. Math, enter, enter. You get 1/4. So when simplifying that, that'll be x minus 1 squared over 4 plus, and if you do that same thing with the other one, it'll be y plus 8 squared over 16. And that's equal to 1. So, expanded standard, you are completing the square twice, unless it's a parabola. Okay, so rewriting the conic in expanded form. Okay, in these cases, we need to get rid of the denominator, so we got to find the LCD of those denominators. Okay, so the least common multiple of 7 and 3 is 21. So multiplying the whole equation by 21. Okay, so again, 21 times that x minus 3 squared over 7 minus that 21 times y plus 5 squared over 3 is equal to 21. Do not forget to multiply the right side by it. That's a common mistake. And what you notice, 21 over 3, or over 7, you're going to get 3 times that x minus 3 squared. So x minus 3 times x minus 3 minus 21 over 3, that's going to be 7 times y plus 5 squared. I'm just going to write that out. It's equal to that 21. So multiplying their two binomials there, you're going to get x squared minus 3x, which will give us minus 6x plus 9 minus 7 times that y squared plus 5y, which will get us plus 10y plus 25 equal to that 21. Now, this is in a hyperbola, so when you distribute this, you got to remember it's negative 7. So 3x squared minus 18x plus 27. And when you distribute that 7, it's really minus 7. So minus 7y squared minus 70y minus that 175. Okay, a lot of people will mess up on your signs there. Okay, you got to distribute the negative with it. Okay, then getting everything in the proper order, your squared terms go first. So 3x squared minus 7y squared minus that 18x minus 70y. Okay, and then 27 minus 175. And you're actually going to subtract that 21 over as well, which will give us minus 169 set equal to 0. Again, in expanded form, it will be set equal to 0. All right, so that is the Chapter 10 or the Conics review. If you have questions, make sure to let me know. Have a good day.